If a day lasted 1 nanosecond, the Earth would be gone before you finished reading this sentence. Not damaged, not cracked, gone, unwound into a ring of debris around where it used to be. And the strangest part is where you'd be standing when it happened, because it decides whether you die first or last. Right now, the Earth spins once every 24 hours. At the equator, that means the ground under your feet is already moving at about 1,000 miles an hour. You just don't feel it because everything around you moves with it. A day of 1 nanosecond means that same ground completes a full rotation not in 24 hours, but in 1 billionth of a second. To do that, the equator would have to move at over 10% of the speed of light. Let that sit for a second. The dirt in your backyard, moving at 100 million miles an hour. For comparison, our fastest spacecraft, the ones that took decades of engineering to build, top out at around 1,000th of that speed. And they're delicate machines, not continents of solid rock. So let's actually watch it happen. And to understand it, we have to start with the force that's already trying to throw you off the planet right now. Because it is. You just always win that fight, until you don't. Everything that spins tries to fling its contents outward. A ball on a string, a fairground ride, a planet. On Earth, that outward pull is called centrifugal force, and at the equator it is very real. It's actively trying to throw you off the ground and into space. The only reason you're still here is that gravity is far, far stronger. Gravity wins by a landslide every second of every day. At current speeds, that outward fling cancels only about 1/3 of 1% of your weight. You'd never notice it. But here's the thing that makes this whole scenario work. That outward force doesn't grow gently as you spin faster. It grows with the square of the speed. Double the spin and the force quadruples. Speed it up tenfold and the force is 100 times stronger. So there is a specific spin speed where the outward fling finally equals gravity, where the fight becomes a tie. For Earth, that tipping point is a day lasting about 84 minutes. That number surprises people. 84 minutes doesn't sound apocalyptic, but that's the quiet danger of a squared relationship. The threshold feels far away right up until the instant you cross it, and then everything happens at once. Not 84 minutes shorter, 84 minutes total. Spin the Earth just 17 times faster than it goes now, and the equator simply stops being held down. At 84 minutes per day, someone standing on the equator would feel their weight drop to zero. They would float. Go any faster, and the ground itself is no longer held together. The planet begins to come apart, starting at its waist. And remember, we are not talking about 84 minutes. We are talking about 1 nanosecond. We are going to blow past that tipping point by a factor of trillions. So now speed it up, not to the tipping point, straight to a 1 nanosecond day. The first thing to understand is that the Earth does not break everywhere at once. It breaks by latitude. The poles, the very top and bottom of the planet, sit on the spin axis. They're like the still center of a record player. The outward force is almost nothing. But every step you take toward the equator, the force climbs. The equator is the outer edge of the record, moving fastest, flung hardest. Think of an old vinyl record. A point near the center hole barely moves, even as the record spins. A point at the outer rim is racing around. Same spin, wildly different speeds, and the only thing that changed is the distance from the center. The Earth works exactly the same way. Latitude is just your distance from the spinning center line, and that distance is about to decide everything. So the destruction is not random. It is a precise geographic wave, and it starts at the middle. In the first slice of time, the equator is moving at over 100 million miles an hour, and the outward force there is not a little stronger than gravity. It is millions of times stronger. The rock, the ocean, the air at the equator are no longer being held down at all. They are flung outward with unimaginable violence. The Earth's crust along the equator tears away first, breaking into building-sized chunks that are thrown into space. The planet doesn't explode outward in a sphere. It flattens and flings from its middle, spraying its own equator outward into a widening disk of debris. And here's the part that decides who dies first. If you were standing on the equator, you'd be among the first to go. thrown outward before your nerves could even register it. But if you were standing exactly at the North Pole, you would feel almost none of the outward force. For a few moments, you would simply stand there. You would not be saved. You would just be last. You'd stand on the pole and watch the planet beneath you dismantle itself from the equator up, the destruction climbing toward you like a tide. It's a genuinely eerie image. Not an explosion you're caught in, but a demolition you get a front row seat to, from the one balcony the spin forgot. But the outward fling is only the first way this kills. Because moving that fast has a second, stranger consequence, one that comes not from spinning, but from speed itself. At over 10% of the speed of light, the rules of physics stop being gentle. Nothing with mass moves that fast without consequences. The energy involved is so enormous that the material being flung outward doesn't just travel, it heats, it shreds, it radiates. The oceans wouldn't have time to boil in any normal sense. The water would be torn apart and flung outward as a superheated spray before boiling even means anything. Every object thrown outward at these speeds carries an amount of energy that dwarfs every nuclear weapon ever built, combined, many times over. And every rock, every drop of water, every grain of sand is now such an object. The atmosphere, the thin shell of air you breathe, would be thrown off the planet almost instantly, spreading out into space too thin to breathe long before you could suffocate. So let's return to you, standing on the pole, the last person alive. Below you, the planet is unwinding. The equator is already a ring of glowing debris. The destruction is a wave of tearing rock climbing up through the latitudes toward your feet. The ground you're standing on is the last part of Earth still holding its shape, and only because you happen to be standing on the one spot the spin barely touches. And then that reaches you too. The pole is not immune. It is simply the final domino. When it's over, and over means a fraction of a single second, there is no Earth. There is a glowing, expanding disk of debris where a planet used to be, spread along the plane of the equator, still carrying the insane spin that destroyed it. No crust, no ocean, no air. Just a bright ring of what used to be the ground, flung across the inner solar system. The moon, suddenly orbiting nothing, would drift off on its own path. The seasons, the tides, the calendar, every rhythm of life that was ever tied to this planet's spin, all of it erased in less time than a camera flash. Which leaves one genuinely strange question to sit with. Everything about this destruction was decided by one thing, not how strong the rock was, not what the planet was made of, just how far each point sat from the spin axis. Your entire survival, by a few fractions of a second, would come down to a single number: your latitude, how close to a pole you happen to be standing. So here's what I want to know. Is that somehow more unsettling than a normal apocalypse, that your fate is decided not by anything you do, but purely by where on the map you're standing? Or is a few extra fractions of a second at the pole not survival at all, just a longer moment to watch? Tell me in the comments. Because the Earth is spinning under you right now at 1,000 miles an hour. Gravity is winning that fight, quietly, the way it has for 4.5 billion years. You just have to hope it never becomes a fair fight. Because the moment it does, the only thing that decides how long you last is how close you're standing to the still point at the top of the world. If you made it this far, you are exactly the kind of person this channel is for. Subscribe, and I will see you in the next one.